All right, guys, hopefully our last Wednesday asynchronous work. And what I want you to start with is the 7.3 worksheet that you guys did yesterday for homework, right? So hopefully you've done all these problems, you're good to go on this. And what I want to do with the video is basically just take this one step further and just graph these polynomials, right? So, the homework key is attached to the homework with this one. It's just a CUDA worksheet, but like let's take the first example, right? So you can't use this one in your the ones that you guys pick, but let's take this first one, x to the third plus 9x squared plus 23x plus 15, right? They gave us x plus 5, which means we could have done synthetic division to find the other two factors, which were x plus 1 and x plus 3. So these three factors, it's called the linear factorization, right? When you write out a polynomial in factored form and then all of it factored completely, so you have all linear factors here. That's called linear factorization. So you get the zeros right from that. But factored form, standard form. And what we want to do to graph it, right? So we have our graph of it. Now in this case, we have, just actually graph it out so we can use graph paper. And let me just write out that equation again. So we had x to the third plus 9x squared plus 23x plus 15. And then factored form was x plus 1, x plus 3, and x plus 5. Okay, so if I was going to graph this, right, I'm going to just use this line here, and we're going to use this line here. Now, we don't have to be super exact when we graph this. I don't want this to take forever. But when you have to graph a polynomial, we're going to start with the zeros. So I know that based on the linear form, my zeros are -1, -3, and then -5. So I'm going to plot those, -1, -3, and -5, right? That's a great place to start because a polynomial, if you have the zeros, you kind of know the direction that it is. Now in our case, we also can extract another point, right? Remember the constant is the same thing as the y-intercept. So I'm just going to say I'm going to go by 5s here, so that way I hit 5, 10, 15 is right there. So that's 0, 15. And you kind of do this a little bit more in pre-calc. So, you can kind of see that the graph, right? So polynomials, now if it's cubic, it'll always start and end in a different direction. So like if it starts down here, it could end up here, or it could also do the opposite and something like that. But basically, you can kind of see how after the 0, it is going to go upwards because it has to hit the y-intercept. And it's not going to turn again, right? It's a cubic. It only is going to turn these 2 times, right? Normally 1 turn, 2 turns, 1 turn, 2 turns. So you don't have to worry about it coming here and then going back down. There are no other zeros. You've accounted for all 3 of them, right? The degree was 3. So you should be good over there. So basically you can just say, all right, well, it's going to go up from here. And then you just know it's going to have to hit these zeros, which means it's going to have to kind of go down after that. Now, how high does this peak go? How high does that valley go? I'm not super worried about it. Certainly if you wanted to plug in like -2 or plug in -4 and get the actual y coordinate, that's great. Now, it might not be perfectly in between, but it's good to do that. But again, just for the graphing today, I kind of want you to just work with the general shapes of cubics. And if you had a quartic, it just has another turning point. But I think that's a good place to start. So what I want you to do for the work is basically graph 3 of these that you did from the homework, completely your choice, and then submit those.